Hello, today we're going to look at solving systems of equations using the elimination method. Now this is going to be part one with what we would call simple elimination, or there will be no scalar multiplication in this. That'll make a lot more sense when we do part two. But for right now, just know that it's going to be our easiest situations. First, I want to do a quick review of what we've been looking at over the past couple days. We already know how to solve a system by two different methods. One is the graphing method. We recognize that if we want to graph something, that has to be in y equals form, and then I can just use some graphing software like the Desmos or the TI calculator, and I can go and find their intersection points. So for this situation, y equals negative x plus 7 and y equals 2x plus 1. Their intersection point is 2, 5, so x equals 2, y equals 5. Further, I've also studied solving system of equation using the substitution method. Now in this situation, only one of the equations is in y or x equals. In this situation, you can look, it says x equals here. So this wasn't really what I wanted to graph, but I can take that x equals 5 minus y, I can come over here and plug it in for x, and then got one equation with one variable. And you can solve down to find y, substitute y back in, and find out that your solution is x equals 5, x equals 6, and y equals negative 1. Now today's method, though, we're going to be looking at the elimination method, and that's where we are today. So here's our situation where both equations are in standard form. Here's standard form. You've got both the x's and the y's on the left, and the constants on the right. One of the variables in our situation, if you notice, is actually the opposite of the other. Right here, I hope you recognize that negative 2x and positive 2x are opposites. And we know from our properties that when you add opposites together, they will equal 0. They're additive inverses. So that's exactly what I'm going to do. I'm going to add both of these equations together. When I do that, you can see negative 2x plus 2x is 0x. I also have to add the y's. Negative 8y plus negative 6y is negative 14y. And 10 plus 18 is 28. Now the good news about that is we don't really need that x. It's gone. And it leaves me with a simple equation that I can solve for y. So if I divide both sides by negative 14, I'll get that y is equal to negative 2. Now I'm going to use this y, and I'm going to plug it into one of these two equations here to find the x. Now the equation is really your choice. It doesn't matter. Just for simplicity, I'm going to choose equation 2. So I'm going to take the y, plug it in, and solve. And here you can now see that x equals 3. So my solution to this equation is x equals 3 and y equals negative 2. Another situation that comes up is that you look at two equations in standard form, and instead of being opposites of each other, like the previous example, you find out they're exactly the same. In our situation here, you realize 5y and 5y are exactly the same variable. Well, adding does not help those eliminate, but subtracting would. So we're going to subtract these equations together. So notice I'm going to subtract these equations together so that I can get my 5y minus 5y. As I do that, you can see I have 1x plus 0y's equals 10. I don't really need the 0, so I'm going to let it go away. And I'm going to solve for the remaining variable, which in this case is easily just 10. Again, take my 10, the variable that I just found, plug it into either one of these equations to find the other variable y. Now, I'm choosing to use equation 2, but you could use any equation you wanted to, either the first or the second. So I'm going to plug in the 10 here, you can see. And now if I subtract 10 from both sides and divide by 5, I find out that y is equal to negative 4. So the solutions for this equation are x equals 10 and y equals negative 4. Thanks for listening. Comment below if you need some help.